Hey there! Today I'm going to talk about a drill press and the mechanical advantage that a drill press presents to the user. So you might ask, why not just use a regular drill? Well, it turns out that the drill press has this crank here that moves this, what's called a spindle, up and down, and because you have kind of a longer lever here, there's a gear mechanism in here that reduces the amount of distance that, or the movement that you get from the spindle when you move the lever. But anytime you get reduction of distance, then that also tends to mean that you get increase of force applied. So we're going to measure that and find out what the mechanical advantage of this drill press is. One way to find out the mechanical advantage of a drill press is to see how far the spindle goes down with the rotation of the lever here. So we can do that and then determine what the mechanical advantage is. So I've lined up the scale here, and we'll see how much of distance it goes when I rotate this half a turn. So that's about half, and that's 1 1/8 inches. Okay, and then we calculate the distance that this traveled around half a circle versus the distance the spindle traveled, and we'll be able to get to our mechanical advantage that way as well. Okay, so we have the lever of the drill press, and it looks like that. And then we can find the distance traveled by measuring the radius, which is this distance there. And I've already measured it, and it is 4.5 inches. Now, we rotated the crank half of a rotation, so to find the circumference of a circle using the radius, you use the equation circumference equals 2 times pi times r, and r is the radius. So, but in this case we're only interested in the distance of half the circumference, because that's all we did was half a rotation. So we're going to just find pi times r. And so of course pi is 3.14 times our radius of 4.5 inches, and that equals 14.1 inches. So we know that the lever on the drill press traveled 14.1 inches, and the spindle traveled 1 1/8 inches. And 1 1/8 converts to 1.125. So I want to simplify that to be some number over 1, and to do that I just run the division, and I come up with about 12.5 over 1. So the mechanical advantage of that drill press is 12.5 to 1. So another way to find the mechanical advantage of a drill press is to measure the forces applied. So I have a fishing scale here, and I'm using that to measure the tension applied to the lever on the drill press, and then I'm using a kitchen scale to see what the pressure is applied by the spindle. So I'll analyze the video that I'm taking here, write down the various points of force applied, both the input force and the output force that I'm getting, and then we'll be able to see if that mechanical advantage lines up with the other mechanical advantage that we calculated with the distance measurements. And it turns out that we shouldn't expect them to be the same because the lever on the drill press has a spring to return the spindle to 0. Okay, so I'm just going to enter the data in that I collected from the video. Okay, so I have an equation here, and this is just, it looks like the data is pretty linear, and that's a good sign. And so we have the equation that we set to a trend line to this data, and the thing that we care about here is the slope. In this case, it's 8.7. So with the spring tension of the drill press, our mechanical advantage actually goes down from the perfect 12.5 that we got from calculating distances, because that doesn't really take into account the actual forces in play. And so we can see that friction and other forces play a role in determining mechanical advantage in a real system. Hey, do you like these videos? Subscribe. I'll make more. Bye.